All right, let's talk about something that's kind of quietly changing everything about our digital world. The stuff that makes self-driving cars and smart hospitals even possible. We're diving into what's called edge computing. You can think of it as the internet's new local brain. So let me ask you something. Why is a split-second delay so dangerous? I want you to imagine this. You touch a hot stove, right? But what if your brain was in a totally different city? By the time that pain signal travels all the way there and the signal to move your hand travels all the way back, yeah, you're already badly burned. That delay, that lag, in the tech world, we call it latency. And in a world that runs on instant data, it is a huge problem.
And the scale of the data we're talking about, it's just staggering. Just look at this number, 40 terabytes. That's how much data one single self-driving car can generate in just 1 hour. Now, trying to send all of that to some distant brain in the cloud, it's like trying to drink from a fire hose. It's just not practical.
And, well, this brings us right to the heart of the problem, doesn't it? Our need, our demand for everything to be instant, for real-time responses, it's pushing the old way of doing things, that traditional centralized cloud model, right to its breaking point.
I mean, the limitations are pretty clear when you think about it. First off, when every single piece of data has to take this long trip to a faraway server, you get those latency delays we talked about. You also totally clog up the network's bandwidth. Plus, the whole system suddenly depends on a perfect, uninterrupted internet connection, which, let's be honest, is not always a given. And on top of all that, it creates all these security risks and can really drive up the costs of just moving all that info around.
So, what's the solution? How do we give our technology the reflexes it so desperately needs? Well, the answer is, we need to start thinking on the edge.
And this is where edge computing comes in. It's actually a really elegant solution. The whole idea is super simple when you break it down. Instead of sending all your data on this long journey to the cloud, you just process it right where it's created. It basically brings the thinking way, way closer to the doing. Now, here's something that's really important to get. Edge computing isn't here to replace the cloud. No way. This quote puts it perfectly. It's not about replacing it, it's about extending it. Think of it like this. The edge gives our devices their own local reflexes for those instant, in-the-moment actions. The cloud, meanwhile, can still handle all the heavy lifting, the deep thinking, and the long-term memory. Okay, so to really get how this partnership works, it helps to think about it as a simple 3-layer system. It's a fantastic way to visualize how all this information actually flows. All right, let's break this down. At the bottom, you have the device layer. Just think of these as the senses, your cameras, your sensors, all your smart gadgets out there collecting raw data. Okay, so that data immediately hits the next layer up, the edge layer. This is the reflexes. This is where local computers and gateways make instant decisions and filter out all the noise, figuring out what's actually important. And then finally, only the most essential, valuable insights get sent all the way up to the cloud layer, the brain, for that super deep analysis and long-term storage. This table here does a great job of laying out the key differences. Just look at the contrast between proximity and latency. The cloud, it's far away from where the action is happening, and that naturally creates delays. But the edge is right there, right at the source of the data. That gives you the absolute lowest latency possible, which is a non-negotiable, it's absolutely critical for any real-time application.
Okay, so that's the theory, but enough of that, right? Let's get to the fun part and see how this stuff actually works out in the real world. Because this is where it gets really, really cool. Believe it or not, edge computing is already the engine behind some of the most futuristic-sounding tech out there. We're talking self-driving cars, truly smart cities, advanced healthcare, wearables, even super immersive augmented and virtual reality.
Let's go back to that self-driving car. It has to make a million split-second decisions, right? Brake here, swerve there, accelerate now. It absolutely cannot afford to send all that data, remember, 40 terabytes an hour, to the cloud and then just sit there waiting for instructions. That's where the onboard edge computers come in. They are its reflexes. They're what keeps the ride safe. Or how about a smart hospital? Picture this, wearable sensors and monitors analyzing a patient's vital signs in real time, right there at their bedside. If something looks wrong, even a tiny anomaly, the edge system can alert the nursing staff instantly, no waiting for a network signal. That's not just about being more efficient, that is literally life-saving. And it's happening in our factories too. Edge devices are completely revolutionizing manufacturing. They can monitor a piece of machinery in real time and predict when a part is about to fail, before it actually breaks.
This means less downtime, and it keeps those production lines humming along smoothly.
So yeah, the potential here is obviously massive, but it's not a totally smooth road ahead. There are definitely some pretty significant challenges we need to figure out as we build out this whole new layer of the internet. The main hurdles really come down to complexity and just sheer scale. I mean, think about it. How do you keep billions of these little devices secure? That's a much bigger surface for attackers to target than just one centralized cloud. And how do you even manage these massive sprawling networks? Another big one, how do you get all these different systems, often made by competing companies, to just talk to each other and work together? These are the big questions that engineers are working on solving as we speak.
But it's really important to realize that edge computing didn't just pop up out of nowhere. It's really a natural evolution. The seed of the idea was planted way back in the 90s with things called content delivery networks, which were all about bringing website data closer to you so pages would load faster. Then things really sped up with the whole Internet of Things, or IoT, explosion in the 2000s. So this whole shift away from one central brain to tons of local intelligence, it's not just some tech trend. We've actually been moving in this direction for decades. And now the pace is just hitting ludicrous speed, thanks to what you could call a perfect storm of three huge drivers. First, we have more of those IoT devices out there than ever before. Second, we've got the rollout of super fast 5G networks to connect them all. And third, we now have powerful AI and machine learning models that are small enough to actually run on these little edge devices. You put those three things together, and suddenly the edge isn't just a cool idea anymore. It's becoming absolutely essential. So this all leaves us with one last really fascinating question to chew on. As our entire world becomes more and more connected, as every device gets its own little set of reflexes, where are we going to draw the line? The line between the local intelligence that's right here next to us and the massive global intelligence of the cloud? Honestly, the answer to that question is probably going to define the entire next chapter of our digital lives.